Welcome to AiTalks, a place to come and listen to IBM customers, partners and colleagues talk about the digital organization and how AI, hybrid cloud and enterprise software is critical to success. My name is Paul Russell, joined by Matthew and Michael from Persistent Systems, one of IBM's ecosystem partners. Welcome to you both. And also I'm joined by Morgan Brown, who is the worldwide engineering ecosystem leader at IBM. And so I'm going to hand over to Michael, who is going to kick us off. Michael, welcome.
Thank you, Paul. First, a very quick introduction of Persistent. We are a company with around 10,000 people around the globe. We are an IT company trying to help our customers in different aspects of their business. The topic today is how we help many customers in different industries with their engineering practices. And, in the current pandemic, customers really have some more challenges with getting ahead, progressing on the things they do. And that comes on top, of course, of many challenges they already have. For example, the automotive industry, where they move into electrification of their portfolio. In different industries, it moves from products being sold to products being used and customers pay as you go for how they use the product. That's where we help. We hopefully have a very interesting conversation. Let's quickly move on. Already talked about the new business models and go-to-market strategies that customers sometimes need to adopt to. With that, they also have challenges from governmental bodies to be compliant with standards that have been introduced into their industries. Of course, what we also see is that AI is being introduced into products, but also into how products are made and how products are designed and implemented. We see the industry is changing. We see that how products are getting developed is changing. And we see that with increased complexity of products and projects, an ecosystem grows, and that is changing, where companies need to be more specialized. And with that, they get challenges. Matt, maybe you can elaborate a little bit on that.
Thank you, Michael. Hi, everyone. My name's Matt Mendell. I'm a solutions architect here in the UK for Persistent Systems. My work is helping companies that practice systems and software engineering to make their processes more efficient. And some of those challenges that you're alluding to, Michael, come generally from the fact that we are seeing growing complexity of products and the processes that go around those products. So in the case of the products themselves, you've got things like the enhanced interconnectivity of different systems. You've got new technologies, you mentioned AI there, that come into the products themselves. You've got greater needs for higher security considerations with all of those products. But also the way that those products are developed themselves has a greater complexity to it. So, for example, one of the things that we see is the idea that the products need to have different versions and variants that's happening in that development lifecycle. So what that might entail is you might have products being released in different markets at the same time, and the development of those streams of work needs to happen simultaneously. This then leads to companies wanting to reuse the data in those two releases, and so there's a strategy around that way of thinking. You also get the increased breakdown, as you said, the specialization, got cooperation between different partners that happens to a greater and greater degree. You've got the silos that exist within those companies having to cooperate in a more efficient manner. So for example, here in the UK, we've got one of our customers is a multinational aerospace and defense company. They are actually being spun off into a company of its own. So for them, it was kind of thinking around how do we kind of break away the IP and the knowledge from the existing parent business, who owns that? And then thinking also about, well, we need to go from kind of this older way of working when we come to managing our requirements into more of what we call this kind of global configuration management. So it's thinking about how do we manage those different variants at the same time? How do we ensure that the complexity that comes from managing our projects doesn't adversely impact our users? Again, how can we kind of reuse the data that we've got there more efficiently, rather from kind of this copy and paste way of working into actually thinking of this kind of multivariant style?
Companies, as they become more specialized, are still trying to grow. For some companies, that means that they maybe have to look into other industries where their technology can be sold, or maybe they have to look to other countries or regions where they can start their business. Is that something that you also see with our customer base?
Absolutely. There's another example here in the UK of another multinational defence company, which was starting up the UK branch from scratch. So they had considerations there, kind of how that existing IP is going to be transformed into a UK context, thinking about any potential liabilities they might have to work around there in terms of the IP ownership. And they were working with the Ministry of Defence here in the UK. So there are security concerns around keeping that data separate. But of course, what they're ultimately looking to do is to spin off the IP that's been used in the parent company here into that UK context. For them, there was also then the consideration of all of the existing systems that they would have to interface here in the UK with. Ultimately, again, it's kind of that idea of complexity. They've got to make sure that there's that architectural integrity to how their systems are going to be developed, and ultimately making sure that their different teams are going to be able to work together between the parent company and here in the UK, and what that process looks like, how the handoff of the data is going to work. Plus, of course, they're then dealing with a whole different set of regulations here in the UK, so they need to work out what that adoption process looks like. And ultimately, what that led them to do is look, again, firstly at this global configuration approach, and also kind of get into the idea of managing all of their models. So they were adapting this model-based systems engineering process, and what that looked like to allow them to maintain the quality whilst, again, ultimately making sure that the timescales around the life cycle of their products were still efficient in the way that they wanted.
Let's say companies changing their position in an ecosystem, with other companies maybe starting to work for different industries, not being limited to one industry like medical devices or the automotive or the aerospace. And I think there are electronic component companies that start to do that. They have to respond to different types of regulations from different industries. And of course, they have to create the traceability between what we call the left side of the V cycle, which is a very known model within the system engineering practice, and the right side of the V model. Basically, the left side is about requirements and understanding what your product functionality has to do, with also taking into account non-functional requirements. And the right side of the V is with respect to validation and verification of those requirements. So it's all about testing. What do those electronic component manufacturers have to do?
Generally, I think the process that you're describing there is what we would call componentization, which is the idea of having, as you say, the entire life cycle, the kind of traditional systems engineering V life cycle, where we've had the requirements defined for a particular product or a component of a product, and then we go through all of the testing process to make sure that the quality of the product is there and it's doing what it's supposed to. Now, what componentization allows us to do is to kind of break out the different elements of a larger system, break it down into a smaller number of components, and run through that process on that component by component basis. That then ties into what we were talking about before with the idea of reuse. So if we do that process once and we're confident in the quality of a component, we could potentially reuse it in the scope of another system where it's appropriate to do so. And this kind of allows us to take a more innovative approach to how we develop our products, because maybe we've got something that's being used for one purpose that could be reused for another that we haven't thought about before. And we don't need to necessarily do all of the rework necessary to get that product ready for release, because we've done a lot of that process before. It's also interesting to think about this in kind of a customer and supplier model, because now we might actually have this not just between different organizations, but in a larger organization, we may be able to reuse a component from another area of the business that we otherwise wouldn't have thought about before.
In 2010, IBM interviewed a ton of CEOs, and one of the things that they talked about at that time was this conspiracy of complexity regarding technology. And just listening to you both talk, you just wonder, don't you, whether that conspiracy of complexity is gone, or actually is it worse?
The componentizing that Matt just talked about is basically what breaks up the overall complexity into smaller parts that can be handled. The way that companies now can do this is they create small V cycles against the components. And then all of the compliancy needs are handled at the component level, and you only have to test and manage the complexity of the integrated components at the end of the bigger V cycle. Matt, based on that example, it brings me to another customer situation that you and I are aware of, which is also a reference for our company, which is Cambridge Consultant. They are a medical device manufacturer company, and they actually had to do a great job, again, based on the pandemic. They needed to come up with life-saving ventilator. So how did the componentized way of working help them?
For them, I think there's kind of three distinct ways in which they were able to kind of overcome the challenges there. So first of all, they ensure that they had compliance with the necessary medical standards and processes. They're obviously working in a highly regulated industry. They've always got to make sure that they're working to that very high quality, and working on that kind of componentized basis allows them to have these smaller V cycles where they can ensure that each of the components complies to those standards and then work with that accordingly. What it also allows them to do is to continually kind of make changes to the individual parts of their systems. So again, each of the components has its own life cycle, ensure that they're working in this kind of more agile way of working where they can make changes to one part of the system without it impacting the other. Ultimately, what this allows them to do is, particularly in the context of the pandemic here, is they're working on a shorter time to market, allows them to be more efficient. They can potentially reuse stuff that they've done before. They can be much more agile and dynamic in the way that they're developing their products.
Many of their knowledge workers were not in an office, let's say, enabled to collaborate easily. So
Absolutely.
Many people were working from home, of course. That adds to the complexity that they have to conquer.
Yes.
And just to mention it, I think, Matt, they can be very proud that normally to create such a life-saving ventilator, it would take 2 years. And I believe they did it in 46 days, if I'm correct.
That sounds about right, yes. They're doing this not just, they're based in Cambridge here in the UK, but they've got sites in the US. And as you say, people weren't working at those sites for the most part. So that kind of remote working that's been emphasized during the pandemic, they needed the appropriate system and services to be able to implement all of that, and of course work internationally as well. So yeah, it's a fantastic achievement.
AI infusing into the system engineering practices. A great example of that where we have used the international chapter of system engineering book written on how you do system engineering. So INCOSI for short. What have we done there? I know we have a great example of how we help individual requirement engineers with creating better requirements.
That's right. So what's actually been done here in the UK is that as you say, the systems engineering body INCOSI has some guidelines around how to write good requirements. What has been done using the IBM Watson technology is those guidelines have been fed into the system to then allow you to run checks against your requirements, where Watson will understand how your requirements are meeting those rules, offer suggestions, give you scores against your requirements, and allow you to ultimately put this into reports so you can get this very kind of high level view of what's going on with your requirements and what the quality looks like. What this ensures is that engineers are spending less time doing things like checking their grammar and the structure of their requirements. It doesn't necessarily cut out review of those requirements, but what it will do is it will cut out a lot of the work in a review to ensure that when you actually go and do that process, it's a lot shorter and a lot more efficient than it would have been otherwise. So it's ultimately saving time and money for a lot of our specialists, our domain experts, and allowing them to do more of the job that they actually need to be able to do.
That's not the end of it. I think if we look at AI in general, one of the examples that's also a reference video on our website is against a company that's doing a big infrastructure project with 10,000 requirements being managed. If you have to check 10,000 requirements, validate them that they are all consistent, that's a hell of a job. And I think also there, AI in the future will help customers to make sure that everything is correct in the set of requirements, not the individual requirements, but the set of requirements. One of the other areas would be testing. I think it's also an interesting area for AI to be introduced. What we see happening is that a lot of the tests always fail or always are successful. Interesting testing that goes on against the requirements is tests that sometimes fail or sometimes are successful. And I know that AI is, let's say, being looked at for helping companies to focus on those types of tests and test results to be able to quicker come to a conclusion about how the requirements are met for certain product, let's say, timelines. So if we look at AI in products, and of course, the interaction, for example, the man-machine interface in cars or in a jet fighter like the F-35, that is also being introduced. What would your perspective be with respect to how we do system engineering in the context of systems that start to embody AI? Is something changing there? How do you validate that the AI is working according to your ethics or the values that you as a company believe in or that you as a society believe in? Is there, do you have an opinion there?
Now we're in some ways we're talking outside the scope of me as a systems engineering expert here. We're just talking about me as a human being. I think I think those questions are still largely unanswered, aren't they? We're still, this is a new territory for us. We need to look at how we are going to establish those standards, in the whole digital realm, really, with all of these new concepts. It's how do we actually, what are the right things that we're going to, what are the values that we need to maintain? And the thing that's strange about implementing those values is, of course, values are different around the world. I think we might see different values for products utilized in China, for example, than we would have here in Europe, because of kind of different ways that our societies are structured. And I think how we actually, again, we're talking about companies working in different markets around the world. How are they going to respond to those kinds of challenges? Are they going to have to adapt AI in different ways for different markets based on what those values look like? So I think these are all still largely unanswered questions.
I agree. When you think about it, we have many non-functional requirements already in products, but probably, and I don't think anyone thought of them, but we might get into ethical requirements in the future too, because of AI.
Yeah, that's a really interesting point, actually. Yeah, that's true. And obviously at the moment we're dealing with, as you say, things that are largely functional. How is that going to change over the next, 10 years or so? I mean, the way that this technology is utilized is going to change massively in that time frame. And so there are going to be all sorts of new challenges which we can't even foresee at the moment. And I think we're kind of seeing a lot of trends in the way that all of the development of these kinds of products are going. But I think there are going to be, this is only preparing us for more of that in the future. And I think that has been consistent in the past in terms of the way that those trends have been going. And I think that's likely to continue.
Matt, Michael, this is fantastic. I was just thinking as you were talking how the UK and all the world has coped with change in agility and all the things you've talked about. And in my head, I can see speedboats and tankers. To me, the UK government or governments are the tanker. They're the classic tanker, slow moving, cumbersome, but they get the job done eventually. But actually, they've had to behave like a speedboat right now, dealing with things pretty much in our face 24 hours a day. So I just wondered, using that as a frame, Matt, can you talk to that in terms of how you are helping tankers go more resilient and more componentized and make the speedboats go faster? Does that make sense?
Yeah, that's interesting. Somebody always used to say to me that IBM was like an oil tanker, and that, if you wanted to see changes, they would happen slowly, but when they happened, you would notice them. I think IBM is an interesting example of how lots of different technology companies have had to kind of be more agile. The evolution from the waterfall approach and how we develop our products, the classic V model, to now, as we're talking about, now it isn't just a series of different teams passing data off to one another, working along one linear life cycle. Now we've got multiple life cycles going on at once. people are working in different disciplines all the time. Those different disciplines are having to work on different projects at the same time. All of that kind of interconnectivity in the way that they're working has caused them to think about how can they more dynamically adapt those processes. And of course, the companies themselves are having to look at new challenges along the way. And I think we've even seen in the case of the pandemic, you've seen companies that are doing one thing pre-pandemic and they're adapting, they're working differently in the context of the pandemic. So they're having to be more agile in the way that they're thinking about that. And everything that we've been describing today is helping that need of rethinking the way of working, being more innovative in the products that they develop, and therefore having more innovative, more agile processes in the way that those products are developed.
Begs the next question, I think, as in terms of maturity and lessons learned. I think we've all experienced them again in our own lives when we've seen things promised that we're going to get done. I was thinking particularly about certain bits of technology that were going to be delivered at certain times and either were or weren't as successful. But actually, in fairness, were probably developed in such an agile way that wasn't necessary at the time. Do you think we're going to find more now moving forward where componentizing and agile testing and the whole kind of mini V approach is going to become part and parcel of how an organization will survive?
It's not just purely a case of here are some challenges that we need to rise to and we overcome those challenges for what we do currently, but actually there's an opportunity there to say, well, look, if we can implement these less rigorous life cycles and we are allowed to do something, we allow ourselves to do something different, then there's kind of an opportunity there to give ourselves a competitive advantage in the marketplace. I expect that what we're going to increasingly see is that companies that are better able to adapt to new challenges along the way using these kind of methodologies are going to succeed more in the future. And so therefore, we're probably going to see more and more of that kind of way of thinking winning out within the marketplace as a whole. And this isn't just going to apply to, classic systems engineering companies, the more kind of traditional companies that work in this way, but there are going to be more companies that I think take on systems engineering like approaches. I think we're already seeing, the classic kind of theme that we talk about in these conversations is the integration of software within systems engineering. So, again, different technologies working together in ways that didn't before. Of course, there's the classic thing about now, there's more lines of code in a car entertainment system than there is in a jumbo jet or something like that. And there's going to be more and more of that kind of way of working, different technologies being used, things that we haven't previously been able to build and visualize because we didn't have the opportunity there in the way that we worked. And there's going to be more and more opportunities for that kind of innovation to take place.
If you look at practices being shared between industries or practices being adopted by, let's say, other departments within an organization, something is coming up which is called multidisciplinary agile development. So basically it's taking software engineering practices into mechanical engineering and electrical engineering. Companies have to learn what KPIs are needed, what synchronization moments in time are needed for the different engineering teams to work together. There's lessons to learn. Take that to the next level. But that's certainly something that is happening within a lot of companies.
Michael, Matt, really, where do you see in the crystal ball systems engineering going for 2021 for Persistent?
Great question, Morgan. Two specific areas where we will help customers. One is a little bit a traditional and conventional answer maybe, but I still think it's important. Many companies are changing the way that they manage their IT infrastructure. And one of the parts where we now see that companies need our help is in the area of moving them into cloud environments or creating better what is called DevOps environments. So to take IT environments from the development to the operations phase. We really have a lot of technology there, and we can also offer managed services to our customers. I think that's a part where we will see a lot of things happening with our bigger customers in the coming year. The other side of it is that we see that within different industries, what we call the variant management in our practices now becomes a reality. So what we call global configuration management, really a practice that comes from the software engineering, and bringing that to the requirements engineering and test engineering practices is something that has a lot of value for customers, especially aligned with the reuse and componentization strategy. For many companies, that notion of what it can bring, what the business benefits are, that really now hits the floor running. And I think we will be helping a lot of companies move from a more traditional requirements management way of working to this global configuration management way of working.
Yeah, I think there's a very clear theme for me, and it echoes some of what we've touched on already, but it's agility, right? We're taking what has previously been a slightly more traditional approach in a lot of ways, both in the processes themselves and how they are implemented, and we're allowing companies to be more dynamic in the way that they work. And that applies to everything we talked about and how they structure their people and their systems, but also in terms of how those systems are actually deployed. So we're looking at a lot of kind of modernization of those systems. Cloud is definitely an option. Going maybe to a managed service is an option. How they're going to actually, rather than just having a more straightforward, here's an application, it sits on a server within my network. How can we rethink the way that we structure that to enable us to be more dynamic in the way that we work going into the future?
And again, on top of that, Matt, going back to ecosystems and how customers can work together, we have seen some great examples of that also in the infrastructure industry. Different consortia members really had a shared environment just for one project,
right.
Which they could use to enable their activities together. Cloud is also an enabler for doing things differently.
Michael and Matt from Persistent Systems, thank you so much for your observations, your openness, and your stories, because your stories are the thing that make all this come alive. So thank you both. To Morgan, my colleague, thank you for participating in AiTalks podcast. And anybody who's listening, I hope you've enjoyed it. And if you have, please tell other people, because we're always looking for ideas to have conversations like the one we've just had. Have a good day.